Hello guys, this is the physics nerd again, and today we're gonna learn about how gravity works. And for a recap, in the last video, what we learned about was basically what gravity is, which of course it is a force. And it's governed by this equation. That its strength is determined by this equation, and that it can be applied to understand why galaxies exist in the way they do, like how elliptic galaxies gravity works and how our galaxies or gravity works. Basically, our galaxy is a spiral galaxy, and how we can use this to get from the Earth to the Moon, or from the Earth to the Mars, and why the planets orbit the Sun. In this video, we're going to talk about specifically how this works, how this force works, and how it was discovered. And some cool things we discovered with using this, other than the fact that how gravity works in certain systems like galaxies and planetary orbits. So, the person that discovered this was a mathematician and a part-time physicist person called Isaac Newton, who basically, the story goes that he was sitting under a tree and an apple fell on his head. And then he was like, why did the apple fall on my head? What force is causing this? Because remember, whenever a mass is accelerating, there's always a force, which we know from the F equals ma equation. So then he came up with this law of gravity, or theory of gravity. Yeah, laws of gravity. We call it the theory of gravity nowadays because we know most laws that Isaac Newton came up with are actually just theories that can be proven with a lot of evidence, experimental evidence. So yeah, what was that? Yeah. So now we're gonna see what that was applied to. So after this theory came out, we realized that Uranus had a weird orbit, and it was basically kind of getting tugged on another planet, which we didn't know about. That was outside its orbit, and what we did was we applied the math of of Newton's law of gravity to Uranus to find out the mass of this object and where it would be, like in the sky, so that we could observe it and see if there was actually a planet there. And the map came out, and and then people were told where it would be based on what the map told them, like about the speed of the planet, its period of like how fast it was going around the sun, maybe not how fast it was rotating, because we wouldn't know that because we didn't know about the planet. So yeah, and people observed that part of the sky, and they found out that there was a new planet out there, which was called Neptune, which we named Neptune. And yeah, we did this with Newton's laws of gravity, which were effective, but not completely effective when it came to things like light curving around uh, an object in space with a lot of gravity. What I mean by that is, let's say you have the sun. Okay, wait. And you were basically, you had a star over here. Yeah, I mean, you had the Earth over here and a star over here. Usually, you'd expect that star to send its rays straight towards something. And it shouldn't get affected by the sun's gravity because it has no mass, according to Newton's laws. Because Newton's laws don't care about the energy, the kinetic energy, or the momentum or velocity of that mass. So, but then we realized that the light actually curves, which causes things like gravitational lensing, where if you had a galaxy, let's say an elliptical or spiral galaxy, when you had stars behind that galaxy somewhere in space, and this was our galaxy, the light would actually curve around them in a weird way and give us this weird image. Oh, wait, no, this is supposed to be one star. And because we're talking about 3 dimensions here, it wouldn't just curve to the left and right of the galaxy, it would also curve over and under the galaxy, which would give us these weird images where we would see stuff like this, and then a galaxy sandwich in between these rays of light. And yeah, and other things that went wrong with Newton's theory was that it didn't work when the gravitational strength of an object was too high, or something was going at relativistic speed, or speeds that reach the speed of light. So Einstein came up with a new theory of relativity that governed gravity in a new way, called general relativity. And basically how it works is, we have the sun over here, and this is a space-time fabric. And what the sun basically does is that it curves this fabric of space-time, and it basically is what causes gravity. And this is because this is like a improvement of Newton's theory of gravity, because now we can explain why things actually don't just go in straight paths. Like light doesn't just go in a straight path when it passes near the sun. So basically how this works, how we would experience it if we were in a spaceship that was passing the sun or the earth or anything with a good amount of gravity, any celestial object, we would be passing it and we would be going in a straight line according to us. But once we get near, like, let's say we were going at an angle, because if we were going straight at it, we're just gonna continue going straight at it, because that's how gravity works. So let's say we were going at an angle over here. We know that there's a gravitational force tugging on this, which would cause it to curve, its path to curve, something like that, into the sun. But here's the thing. From the observer on the spaceship, they're still going straight. They don't know that they're actually falling into the sun, because that's how the geometry of the space-time curvature works, which basically means that in that curved space over there, when we're going in a straight path, that path actually curves with that space, because the space is different from the normal space, like that's not as, where gravity isn't affecting it as much. So yeah, this is what Einstein came up with.